In lesson 3 of polygons, let's do some of the examples. Label the quadrilaterals in this picture. First of all, the picture ends up being a bit of an optical illusion. I should think of the title of that. It looks sort of like this line in the middle here ends up being curved, but it is actually, of course, dead straight if you take out your ruler. You'll see. I try not to make this one too difficult. Let's just label things as best we can. This shape here, what kind of shape is it? I believe it's a trapezoid, because I believe this side is totally parallel to this side there. I believe this is a trapezoid. If you want to call it an isosceles trapezoid, because this side equals this side, feel free. But most importantly, it's a trapezoid. Next one over. What kind of shape is this one here? I believe this one is a parallelogram. P for parallelogram. I believe this one also is a parallelogram. This one here is an isosceles trapezoid. What's this one here? Can you see that if you draw this diagonal and this whoa, that was a bad one. And this diagonal here, can you see them meeting at a 90? Can you see that this one is K for kite? Now how about this one here? Is this one also a kite? This side is equal to this side. You can talk me into that. I don't think you could talk me into saying that that side is the same length as that side. I think they are different lengths than each other. I think that one's a cube. I think that one's a quadrilateral. I don't think it has any other features to it. You can't call it a trapezoid. You can't call it a kite. You can't call it a parallelogram. You can't. It's just a four-sided shape. It's a quadrilateral, I believe. Are there any other shapes available to us? I think all of the rest are all double ups, aren't they? Like this one's still a parallelogram, I got that, and this one's still a trapezoid, I got. But I think we already did all the rest. I'm going to move on. This one. What type of quadrilateral is? That's a typo. Is. A, B, C, D. Parallelness, so that's telling us this is definitely a trapezoid. And if this angle is 60 and this angle is 60, that means this angle and this angle are locked in and the same as each other. That to me tells me it's an isosceles trapezoid, and that's an S, sorry. And so we can absolutely do, that was supposed to be green, C rule in this corner. We can do C rule in this corner, and so angle A is 180 minus 60. Remember, in the C rule, the two angles together make 180 as a total. So I believe angle A is 120. And if this one's 120, so is this one. Because if this one's 60, because this one is 60, and so is this one. If it's isosceles, then we know this length has to also be the same as the other side. He also has to be the 4 centimeters. And that's everything they asked. Perfect. Good. Find WX. Well, again, here's the telltale sign. If there's a 90 in there, then we know we're dealing with a kite. And we know if we're dealing with a kite, then the sides that are next to each other are the same. If this one's 3, this one's 3. If this one's 2, then this one should also be 2. That's how kites work. And therefore we found WX. WX is 2 centimeters. Angle XYZ. Angle XYZ. Angle XYZ would be this angle in there if I connect it all in order. Ah. Did you notice on the kite earlier that I call them the shoulder angles? The angle here at this shoulder and the angle here at this shoulder should be the same size as each other. Again, I imagine if this one was a different size, do you see that it would pull this side in or push it out, and then they wouldn't be the same length anymore? Let's undo that. You don't want to see those dumb arrows. But anyway, that angle there has to be 101 degrees, the same size. Angle XYZ is 101 degrees. What is the sum of angle WXY? WXY makes this angle. YZW makes this angle. So let's call it angle A and angle B just for similarity. A and B. What do A and B add up to? Well, here's the deal. In a four-sided shape, the angles always make 360. We know this angle is already 101. We figured out that by symmetry, this side over here should also be 101. So we have only so and so many degrees left over after that. I should be able to do this in my head, but I don't trust it right now. I got 150. Whoa, not good at all. Let's try that again. I got 158 degrees for the last two angles. At this moment, we don't know the size of A and the size of B, but we do know that together they have to make the rest of the 158 degrees. Could we find them? Probably, if we used our sine law or cosine law or SOHCAHTOA or these sorts of things, we could find it. But at the moment, all we know is that they're not the same as each other. If this is 2 and 2, this is a much wider angle because this is 3 and 3, and that should make it much more pointy. So A and B aren't the same as each other, but I know that together the two of them should make up the rest of the 158 degrees, because then this one plus the 201s would make 360. Example 2. Example 3. J makes picture frames. The interior angles of the square picture frame have a sum of 360. How do we know? Well, because each of them is 90 degrees, and there's 4 corners, and so there's the math. 4 times 90 degrees is 360 degrees. How can you draw a diagonal to show that all quadrilaterals have this property? Well, if we draw a diagonal in here, then we have 1, 2 triangles. Angles in this triangle are 180. Angles in this triangle are 180. If the two triangles together make the trapezoid, then the two 180s together should make 360 degrees. As long as you can divide the shape into two triangles, you know it should add to 360 degrees. Can we divide this one? Sure we can. Can we divide this one? Sure we can. How about this one? Sure we can. How about this one? Sure we can. And this one? Yeah, him too. He can also be divided into two triangles. Even if you have some weirdo four-sided shape. 1, 2, 3, 4. It's nice and weird, isn't it? Can I divide it into two triangles? Sure I can. Two triangles, 180 degrees each, 180 degrees each, 360 for the total. And then off you go with the lesson 3 assignment. See you soon.